Hello, Robot X. How is your funky Chumby robot doing?
Hi guys. I haven't worked on my Chumby robot lately.
Oh,
I've been busy with another project.
oh,
Yeah, I have something that I would like to kit. You can see this little guy here.
what's
Let
on
me.
its head?
Yeah.
Or, I don't even know. What is that pointy shaped palm tree thing?
Yeah, it's like a chicken head or something like that. I guess you can put your robo bird, micro robo bird on top of it or something like that, you know. It's supposed to have two RGB LEDs as eyes, but I don't know, I messed something with the resistors or something, and they stopped working for some reason. It has a small piezo beeper, and this the head. Let me get a better image. Okay, the head just unplugs. It's
Oh,
held with some
nice.
tiny, yeah. So you can see. I don't have a very good light here. Okay, there is the Arduino controller right there, FTDI connector. Down here there are two infrared LEDs and an infrared sensor, some capacitors, trim pots, and stuff like that. So basically, this is a biped. These are the legs. There are two servos on each leg. So there is a rotate servo, and then there is a tilt servo.
Nice.
Yeah. So let me show you what it does. Okay, let's start it up.
Oh, you
Oh,
can do shuffle.
one servo. Oh, 1 second. I have problems with oh, see, I got some LEDs, but one servo has a problem with the wire. Yeah, now it works. Yeah, of course. Yeah, now it works.
Oh, this is
When it will see an
awesome.
obstacle, uh, I think the battery is pretty low. Okay, so now it sees an obstacle and it will turn the other way. Then it will walk forward.
Does it beep when it changes direction?
When it detects obstacle, then when it resets, also beeps. So um, I set the microcontroller to the low voltage watchdog to 2.7 volts. So when the battery gets a 2.7 volts, it resets. So then I know that I have to put it on charge. The battery is a 3.6 volt lithium ion with tabs that are soldered directly to the board. And when I plug in the FTDI cable, it will start charging. Okay. So of course, when it has 5 volts plugged in, then everything works. See, now it detects an obstacle and it will turn on a different color each time there. If the obstacle is on the right, it turns blue. If it's on the left, it turns green. If it's on the front, it turns red. So it
Oops.
works kind of like that.
Wow. Wow. Oh, that's so much awesomeness in one small package. Uh,
Yes, and I've seen these robots built by kids at the school in Hawaii. I contacted the guy that built them. The company is Easy Botics, and I contacted the guy and I asked him if I can make a similar kit with an Arduino controller. He's using a PIC, and he said, "Sure, why not? Just go ahead and just let me know what you have, and maybe I'll buy some from you." Because he sells at schools. He takes these robots to schools, have the kids assemble them, and then play, have the robots dancing on music, or have them race. The fastest one that crosses the line wins. Or they have a sumo competition, like they put a paper plate upside down, and they set the robots on the plate facing each other. By the way, those robots don't have any sensors, just the four servos and two bicolor LEDs, and that's about it. And the robots will jump around and try to push the other one off the plate, and of course the first one that gets outside loses. So yeah, they're having fun. So I saw the possibilities, and I thought, well, an Arduino has much more features, and so I can put in one robot, like a beeper, which can also play songs. Then RGB LEDs, so you can fade in, fade out different colors, or just plain colors for whatever reason you have. When dancing, flash different colors, and also add some infrared proximity sensor on the robot, so it can detect an obstacle, and especially for the sumo competitions, when robots can go head to head and find the opponent easier. So yeah, I thought it's a nice project to do.
wow. That's awesome. So
Yeah.
there's a total of four servos on that robot, and you have
Yes.
RGB LEDs, which is
Mm-hmm.
cool. And the way that the battery works, that's sort of interesting. So, what exactly did you do with the like? You said some sort of interrupt or something like that. How did you do that?
Oh, to cut off the I have two things on the, because the lithium ion batteries, you're not supposed to drain them lower than 2.7 volts. So I have the microcontroller watchdog set to reset the microcontroller when the power drops to 2.7 volts. Then I know that the battery needs recharging without using actually a battery sensor. I thought of using a battery sensor also, but I didn't implement it in yet. This is just a prototype robot. Um, for charging the battery, I have a tiny battery charger called Max 1555, and it takes power from USB, the 5 volts, and just connects to the battery even without the power switch to be on. As soon as the cable is connected, the battery starts charging. Um, it also has an LED which indicates charging, but I put a resistor too big on it, and it doesn't shine too much, so I have to replace that resistor with a smaller value. The board also has four extra ports where you can plug, say, two servos for arms or two servos for a pan and tilt, and two extra sensors like a ping or a sharp or whatever. So the the board still has expandability.
One of the cool, expandable parts I think that the students will love is that you'll be able to make different heads for it, right? Because you have
Yes.
it unpluggable and pluggable. They're gonna go
Hmm.
crazy with that. That's so cool.
Yeah, and so the kids can customize it. I also thought about having the head instead of like this, like a mohawk head, you know, plug it like like this. So there is just a generic, two eyes and the speaker in the middle, like a nose or something like that. And the kids can cut some cardboard with holes, and plug it over the board, and paint it and
Yeah,
draw it, whatever, and cut whatever shape they like, to customize the robot.
cool. I sort of like the mohawk look though, because if you think about it, your robot is either going forwards or backwards, and that's the way the head is pointing, right? Because you would never really be able to see it face on. It just wouldn't make sense. So it may be
Yeah.
fun to just do something different and do mohawk look. It's because
Hmm.
uh, you could maybe make a modification sort of kit to go with your kit that would have like
Hmm.
e-text style sensors so that thinking about the mohawk sensor when they're brushing the mohawk, then they're learning about sewing e-textiles and sensors, and it looks cool.
Hmm.
How do
Yeah,
you?
I guess.
Oh, sorry. Go ahead.
Yeah, I guess the extra ports can be used for sensors or servos, so they can add anything to the to customize it. Even put some what do you call them, like a band sensors,
Yeah,
something like that,
yeah,
or
yeah,
just a resistive foam,
yeah.
that when you squeeze it, it changes resistance, so you can use it that as a sensor. It's like a petting the robot, and then it will start dancing or do stuff. You know, to be more interactive.
Yeah.
And of course, the infrared sensor can be used with a remote control, so you can actually uh, remote control the robot, go forward, turn, whatever. And the speed that you saw, it's a very slow speed because I just wanted to see how the steps are going. I can increase the speed.
Wow.
It can go much faster.
Wow. That's
Yeah.
cool.
Yeah, so I wrote these functions like primitives, for each leg to turn the servo one way or the other. And you can specify, then using those primitives, you can make moves like a forward move. Then you define the steps. Then you can say forward, how many steps, and the speed. A lower value like 20, it will make it goes through the for loop faster than if you put like a 40 value, then it works slower, so you can really see what's happening. Or you can make the speed like I made it 10, and it cuts through the for loop because the servo gets updated every 20 milliseconds. The position every 20 milliseconds. But if you make the for loop goes in 5 steps, let's say, and each step you send the command to the servo every 10 milliseconds, then two steps, I mean, one step will be skipped and it will actually update every other step, So it will go even faster through all the steps. It's like having just the start and end position, and then it goes, it goes so fast. So, but it may break or something. I haven't tested it that fast.
S- I love I love robust programming designs like that. One of the things that is interesting is, do you think that because you programmed it so robustly, you could make adaptations for it to in maybe Scratch? So, like for instance, that may not be the best way for students to learn, but if they're really really young students, maybe then you could get them interested in it by having it in Scratch or RG blocks like Sean suggested. Are you going to make bindings for it in Scratch or whatever they call them?
Yes, I thought about this. I tried to write all these moves that you saw the robot doing. I tried to write them in RD blocks. The only problem that I have with that is that I can't create my own functions because it takes me like 3 or 4 hours, just to write all these movements, with all the blocks, and because I don't have a copy paste,
Yeah.
so every time,
Wow.
yeah, it's very very hard to make it like that. If they create the function blocks that are editable, so I can write the functions for the legs, then it's easy. Then just put the like forward how many steps and left how many steps and then stuff like that. So then it's easy programming. So
Cool.
sure, if we can do that.
Yeah, so Sean thinks that this project is an awesome project.